Alright, so in the previous part, we did 3 basic results. 3? We did 2. Okay, I'll just recapitulate what happened in the previous part. So first thing we learned that in a triangle, sum of any 2 sides, in fact I should say in a triangle, sum of every 2 sides is greater than the third one. Right? Okay. There was another way to write this. There is another way to say this in fact. The difference of any 2 sides is always less than the third one. Right? In fact, we did another thing also, the converse, that if there are 3 points in the plane such that AB plus BC is greater than CA and BC plus CA is greater than AB and CA plus AB is greater than BC. If these 3 conditions are satisfied, definitely the points A, B and C will form a triangle. Right? These are 3 basic results and now we will be learning to apply them. Now these results seem so simple. ये तो पता ही है हमें 7th class से, true. But now let's see whether you can do the questions. I'm sure you can. But the thing is, the questions are quite interesting. These are basically questions which will improve your perspectives, which will increase your perspectives, I should say, not improve. Right? So let's see how you fare. So first question, write down. In triangle ABC, AD is the median. Prove AB plus AC is greater than 2AD. In a triangle, AD is the median. So ABC AD is the median. Obviously, we know what a median is, right? Yeah, we do. So I need to prove that AB plus AC is greater than 280. Alright, clearly we know triangle inequality. Sum of 3 sides is greater than the third one. But that happens in the single triangle itself. Now here, AB is here, AC is here. Then 2AD, मेरे पास तो AD है. He says you need to have 2AD. Where is 2AD? I can't see any 2AD. If I want to apply triangle inequality, I should have a triangle which have the side 2AD. But clearly I don't. What should I do in this case? When I don't have something in math, what should I do? I need the length 2AD. I have AD. I need twice of it. So what I'll do is, I'll extend this. Extend AD to a point E such that this AD is equal to DE. Right? Because this length, AE, will be 2AD. AE is equal to 2AD. A very important step of construction, which is extend AD to E such that AD is equal to DE and which will make AE twice of AD and twice of AD I do need. Right? So अब मुझे prove क्या करना है? I need to prove that AB plus AC should be greater than 2AD, but I can write AE. This I need to prove. Right? AB, AE. अब ये तो आ गया. But AC तो यहाँ पर है. AB, AE. Sort of same triangle में कैसे आएंगे? अगर मैं इसको join कर दूँ, in triangle ABE, AB is here, side of the triangle. 2AD is there as the side of the triangle. But AC तो यहाँ पर है. AC यहाँ पर है. Oh, wait a second. Don't you think that AC will be equal to BE? These 2 sides seems to be equal. Why? Wait a second. If consider this triangle, consider this quadrilateral ABEC. Let me join this. AE is a diagonal, BC is a diagonal, and clearly these two diagonals bisect each other. What kind of a figure is this? ABC is a parallelogram. In a quadrilateral, if diagonals bisect each other, it will be a parallelogram. Parallelogram, opposite sides are equal. This is AC, this is AC. Right? मुझे प्रूव करना था AB plus AC. अब AC तो BE के इक्वल है, तो मुझे प्रूव करना है that AB plus BE should be greater than AE. AB plus BE should be greater than AE. Obviously, in triangle ABE, okay, I should not say that, right? In triangle ABE, sum of two sides AB plus BE, AB plus BE is greater than the third one, which is AE, by triangle inequality. राइट अब वापस सब्स्टिट्यूट कर दो बीई क्या था एसी के ऊपर जो मैंने उल्टे स्टेप सिखाया ना अब लिख दो राइट ए इज नथिंग बट 280 एंड प्रूवन डन नेक्स्ट oh next one is nice write down S is any point in the interior of triangle PQR. S is any point in the interior of triangle PQR. Proof PQ plus PR is greater than SQ plus SR. Come on, hurry up. Triangle ABC. ABC. S is any point in the interior. So let me take S over here. Right? I need to prove ABC क्यों लिया? Triangle का नाम PQR था ना? Of course. आदत हो जाती है ना? Right. Triangle name is PQR. Right? Now you need to prove that PQ plus PR is greater than SQ plus SR. So let me join SQ first and SR. Right? Okay. I need to prove it. So again, the problem is PQ is here, PR is here, SQ is here, SR is here. Now you will say, ma'am, these sides do not come in the same triangle. So let's find some triangle where these sides come. Q plus SR चाहिए, फिर PQ plus PR भी चाहिए, क्या कंस्ट्रक्ट करोगे? अब it doesn't seem like that I can arrive at this using single triangle inequality. Till now, in the questions we have just used one triangle inequality, right? We chose one triangle, sum of two sides greater than the third one, and answer is there. But this question doesn't seem like that I can just do with one triangle inequality. Okay? So whatever I can achieve, let me do that first, right? अब PQ plus PR है, अब PQ के साथ PR चाहिए, अब PR चाहिए, मुझे SQ भी इन्वॉल्व करना है, अब PQ SQ यहाँ पर है, तो ये ट्राइंगल तो नहीं बनेगी। What I'll do is I will extend this. Yes, sir. Let me extend QS to the point T where T lies on PR. Step of construction, a very important step. Extend QS to T, where T lies on PR. Why did I do this? Look, I need to involve PQ, I need to involve PR, I need to involve SQ. So PR and SQ, yeah, part of it, involve हो रहे हैं, right? And यहाँ पे PT is getting involved, which is a part of PR. So let me do that. So, in triangle PQT, PQ and this side I can take, right? अब मुझे SQ चाहिए उस side पे. So what I'll do is, I'll say PQ plus PT is greater than QT. Why? Because SQ मुझे इस side चाहिए. So that's why I kept QT on this side. Right? Okay. Now what else? अब मुझे SR भी इन्वॉल्व करना है somehow, right? और since अभी तक I've just involved PT, right? I need to involve this part also. I need to involve both the parts in order to get PR. So I need to involve this, and I do need to involve SR. So I think I know which triangle to use, right? So consider this triangle now, STR, right? Now SR को मैंने उस side पे रखना है, right? So what I'll do is I'll say that this plus this is greater than this. So I can write TR plus ST is greater than SR. Right? Okay. Now let also मुझे SQ चाहिए था ना, QT पूरा क्यों लिख रही हूँ? SQ चाहिए, so let me break it up. So SQ plus ST. Write QT as SQ plus ST. I think we know what to do, don't we? Add the two equations. Add the two inequalities now. Right? So PQ plus PT plus PR आएगा, right? PT plus PR, PT plus TR, which is nothing but PR. Combined plus ST greater than SQ plus ST plus SR. Oh, ST cancel. Great, perfect. आ गया मेरा आंसर. PQ plus PR greater than SQ plus SR. क्या प्रूव करना था? हाँ, same. And proved. Done. Next one. Write down. Find a point in a convex quadrilateral. Find a point in a convex quadrilateral such that the sum of distances from the point to the vertices is minimal. It is minimal. It's a weird word, minimal. No? Come on, hurry up. Now, first of all, I hope we know what convex quadrilateral is, where each angle is less than 180 degrees. Basically, the normal quadrilaterals that we deal with, that is convex. Right, so let me have a convex quadrilateral. Yeah, कोई special quadrilateral तो नहीं लग रहा? No. So A, B, C, D. Now, I need to find such a point that sum of its distances from all the three vertices is minimal. I don't understand it. What is he trying to say? So let me take this point, P. Right? I want sum of the distances from this point to the vertices. So let me take the distance of this point from this vertex, which will be this one. Right? From this vertex, which will be this one. Then this one. Then this one. So basically, PA, PB, PC and PD. These are the distances, and he is talking about the sum of them. So PA plus PB plus PC plus PD. These are the sum of distances. This should be minimum. I need to find such a point such that these distances, this sum is minimum. Okay, now I understand what he is asking me. Right? Now I'll proceed. Okay, so let me draw the diagram again now because I finally understood the question, what he is asking me. So let's use it. So my quadrilateral. Oh, again a bad one. So I need fat, not fat, but yeah, a big one. Right, so this is my quadrilateral ABCD. Now I want to locate such a point P such that the distances are minimum. Okay. So distances from the vertices. So let me consider this vertex A and vertex P. First of all, let me locate that point whose sum of distance from these two vertices is minimum. If I talk about all the four vertices at once, I'll be confused. So let me take these two vertices. And I'll make sure that the sum of distances is minimum. Right? I'll find such point. Right? So this is point P. Right? I want PA and PC. I want PA plus PC to be minimum. अभी तक मैंने पढ़ा क्या? Till now I have used what? Triangle inequality. Now triangle inequality is sum of two sides is greater than the third one. Right? Now I want this to be minimum. ये minimum तो तभी होगा ना जब ये इसके equal हो. Right? And now wait a second. PA plus PC. है ना? PA plus PC. Now in a triangle, PA plus PC. So I can have this triangle basically. So join AC. So this triangle APC. I know that PA plus PC is greater than AC. Is greater than AC. This I know, triangle inequality. Right? But I want this to be minimum. Now this will be minimum if this is equal to this. If this has to be minimum, I have to make sure that PA plus PC should be equal to AC. I want this. PA plus PC should be equal to AC. That means where should P be? In fact, P, it cannot be here. P cannot be here. P cannot be here. P has to lie on this line itself. If I take a point P over here, PA plus PC is equal to AC. So a point which has the sum of distances from these two vertices minimum lies on this line itself. Right? You can take it to be this point, this point, this point, this point. Any point on this line. Right? Okay. This I understand that P lies on AC. Right? Now, till now we have just talked about A and C. What about these two? Let's talk about this now, these two. So let me erase this again. On the same lines it would be. Now, I am trying to locate the point Q such that BQ plus QD. BQ plus QD. This should be minimum. Right? Now, first of all, BQ plus QD. Definitely it will be involved in a triangle. Right? Sum of two sides. So let me consider BQD, this triangle. So join these two. BQ plus QD is greater than BD. Right? But I want this to be minimum. Minimum, it will only happen if BQ plus QD is equal to BD. Then only this minimum will happen. So now tell me, where will Q lie? Definitely Q will not be here. Q, again, it will lie on this line itself. PQ plus QD is equal to BD. Q will lie on this line. Right? Such that the sum of distances is minimum. Right? My question was that sum of distances from all the vertices should be minimum. Okay. Now, let's see. Let me erase this. Minimum distance from B and D lies on this line. Minimum distance for A and C lies on this line. A minimum distance यहाँ पे भी involve होना चाहिए, यहाँ पे भी involve होना चाहिए. Which is that point which lies on this line itself and this line itself. Obviously, the point of intersection. PA plus PC is minimum as well as PD plus PB is minimum. That means sum of all these four would be minimum. And this is that point. And this is nothing but the point of intersection of the diagonal of the quadrilateral. So it is such a special point. The point of intersection of the diagonal is that point such that the sum of the distances of this point from all the four vertices is minimum. Such a special point. Usually we ignore it. Intersection point of diagonals. Who cares about it, right? Especially in a quadrilateral. We don't care. Actually we should. It's a nice point this is. Right? Okay. Let's move on to the next one. Write down. Find the number of values of B. Find the number of values of B for which There is an isosceles triangle. There is an isosceles triangle with side length b minus 3, 11 minus b, and 2b minus 5. Find the number of values of b. Small number of values of b. Hurry up. Right. I think sufficient time. Now, if I want there to be an isosceles triangle with these three sides, now two type of conditions need to be satisfied. First of all, these lengths should be able to form a triangle. That means sum of any two lengths should be greater than the first one. Third one, I should say. Sum of any two sides should be greater than the third one. Right? If that is the case, then it will form a triangle. Right? Now, second type of condition is I want an isosceles triangle. That means two sides, two lengths have to be equal. So it depends on you whether you want to start with triangle inequality condition or do you want to start with isosceles triangle condition. Now, I would say this condition is easier to check as compared to this one because इसमें पहले ये करना पड़ेगा, फिर ये, right? So it takes time. So I'll start with this one, isosceles triangle condition. Now, isosceles triangle, that means two sides, two lengths are equal. So first case, b minus 3 is equal to 11 minus b. These two are equal. Second case, these two are equal. b minus 3 is equal to 2b minus 5. Then these two are equal. Third case, 11 minus b is equal to 2b minus 5. Three cases. Let's check one by one. Now, from here, I can get 2b is equal to 14. Then b is equal to 7. Right? Let me check the side. So 4, then 9. Now 4, 9. Clearly, sum is what? 8. And 8 is not greater than 9. Right? Now that means in this case, triangle will not be formed. Rejected. Great. Now from here, I can get b is equal to 2. B is equal to 2. 2 minus 3 minus 1. Side length is negative. Come on. Not possible. Rejected. Right? That means this one. Now I have 3b is equal to 16. So b is equal to 16 by 3. Right? So let me write the side length. 16 by 3, 16 by 3. And first one will be b minus 3. So 16 by 3 minus 3, which is 7 by 3. Right? Check. Sum of these two should be greater than this, which is true. Sum of these two should be greater than this, which is true. Sum of these two should be greater than this one. वैसे वो हमने कर लिया था, but okay. In this case, triangle will definitely be formed. That means for b is equal to 16 by 3, for just one value of b, I am getting an isosceles triangle with these sides. Right? So it was easier to start from isosceles triangle condition. Decision making. Right? Oh, next one is interesting. Write down. A man walking from A wishes to reach a river. The straight line A1, B1 in the figure. A man walking from A wishes to reach the river, this is the river, and then go back to B. From A, he wants to reach the river and then he wants to go back to B. Suppose B is here. Right? How can he do this? Yeah, it's a practical problem apparently. How can he do this? By traveling the shortest possible distance. Because apparently he is just like me, he refuses to walk. Yeah. I'll repeat. A man walking from A wishes to reach the river and then go back to B. How can he do this? By traveling the shortest distance possible. How should he travel? Which path should he take? That's the question. Come on. Now, first of all, understand the question. He wants to start from A, then go to the river, then go back to B. And he wants to travel the shortest distance. Maybe he can go like this. Maybe he can go like this. Maybe he can go like this. Right? Out of all these paths, you need to find the shortest one. Right? So locate that point. Basically, you need to locate that point. This one. Where is it? Locate that point. So I'll draw my figure again. This is my river. So proceed in a very systematic manner. You need to investigate where will that point be. So start in a very systematic manner. Investigation करनी है. कैसे करोगे? Point ढूंढना है. Point कहाँ पे होगा? What I'll do is सबसे पहले यहाँ से perpendicular drop करो. Let me see whether the point is here or not. Right? The point that I'm looking for, maybe it is here. Let's see whether this distance. पहले वो यहाँ तक जाएगा, river तक पहुँचा. Right? He reached there. Now he has to go to B. I need to check whether this plus this is minimum or not. So let me call this B. So AD plus DB. Check करना. Minimum है? Definitely not. इसमें तो ये 90 degree है. AD ये वाला part पड़ा है. So AD is greater than AE. Right? And BD is definitely greater than BE. BD is greater than BE. So definitely you can't say that AD plus BD is the minimum one. No. Right? यहाँ पे भी लोग same problem. यहाँ पे भी same problem. Right? So basically on this side, perpendicular drop किया, on this side of A, there will not be the point. You will not find it here. Did you investigate this? You have to locate the point. It can be anywhere. It can be here. Investigate. अच्छा मैंने इसके left hand side की है, मैं यहाँ से perpendicular drop कर देती हूँ. Now tell me, do you think I will have the point over here? Again not. पहले वो यहाँ तक जाएगा, फिर वहाँ तक जाएगा. वैसे ही distances इतने लंबे हैं. Right? So definitely the point will not lie here. Point does not lie here. That means if I have to look for that point, where do I see? I locate them between E and let me call this F. Between E and F. On this line segment, I need to find that point. Okay, done. This much investigation we did. Good. Some part I reduced. पूरी line में से कुछ part में check करना है कहाँ पे होगा point. That I can do. Not a big deal. So the river again. Now somehow उसकी width मैंने बढ़ा दी मैंने because मेरे को diagram बनाने हैं. That's why. B. Right? Now if I have to locate the points, I have to locate between E and F. Right? Okay. Now minimum distance चाहिए. Minimum distance. अब suppose मैं point ले लेती हूँ D. D में use किया मैंने? No. Now I want D such that AD plus DB is minimum. AD plus DB is minimum. Till now we have been using what? I think last question we did something like this. Right? Sum of two quantities should be minimum. What we did was that AD plus DB. अब triangle ढूंढो पहले. AD plus DB and ये वाली triangle बना देती हूँ मैं. ABD. Now I know that AD plus DE is equal to AB. Is greater than AB. अब minimum चाहिए था. What I did was minimum तभी होगा when this is equal to this. So AD plus DB should be equal to AB. But with this condition, where will D go? D will go on this line. Right? D will be here. Right? but मुझे D कहाँ ढूंढना है? I need to find it on the river bank, not on this line. Careful. That means we do need to apply triangle inequality, no doubt about it, because minimum question. But you need to be wary of the type of triangle that you have to use. You can't use this triangle. You will get your D over here. No, we don't want that. So find the suitable triangle. Suitable, come on. Suitable triangle, let's find. Line straight line, yeah. One, find the suitable triangle. This is the best I can do. AD plus BD has to be maximum, has to be minimum. I don't know how to proceed. That's the problem. Now, I will remind you of something that you did in class 8th, I guess. I'm sure you are in class 10th or 11th, right? You have done your class 8 quite nicely, right? So, there was this experiment. Maybe you have done that in school. Yeah, because 2 years back schools were going on and practicals were happening. But now they are not, but okay, right? We did this thing. What we did was, we stuck 2 pins. Then the light was crossing, not crossing, like shone light through this. It got reflected and it got reflected like this, right? And you stuck the pins here, right? And what you did was, you measured the angles, right? Angle of incidence, angle of reflection, right? Do you remember what I'm talking about? I'm talking about the Snell's law. So you will be like, ma'am, Snell's law? What are you talking about? Here we have minimum distance. You're suddenly talking about physics now. Basically, I'm talking about the reflection. Look, you can't involve AD directly, right? Because AD plus BB, it forms this triangle. You can't involve this thing. You need to translate this side somewhere. Translate करेंगे. Translate करें. What I'll do is, I will take the reflection of this point A in this line, A1, B1. Can I take the reflection? So, इसकी reflection मैंने ली, तो इतना distance नीचे, अच्छा हमको नीचे दिखाने पड़ेगा ना, right? Maybe here, right? So, A dash is the reflection of point A in this line, right? Now, suppose I join, no. D and A dash. Let me join these 2 points. Right? See line within line. Let me exaggerate this a bit. Right? Okay. Now, AD plus DB involved करना था. Now, AD I can clearly see is nothing but A dash D. These 2 lengths are equal. Why? Because these 2 are equal, common side, and obviously 90 degrees. These 2 triangles are congruent, and I can say that AD and A dash D, these have to be minimum. Right? Okay. So, मुझे क्या करना था? AD plus DB to be minimum, right? इसकी जगह I'll do A dash D plus DB to be minimum. Right? My diagram now doesn't give that perfect sense. So let me do one thing. Let me just rectify one thing so that you can clearly see what is happening. So my point A, right? Now let me take D here because I want to exaggerate something so that you can actually see what is happening. So A here, right? So I want AD plus DB to be minimum. Right, so what I did was, I took the reflection of A in this line. This point was A dash D. Right, if I join D dash and if I join D and A dash, I can see that these 2 lengths are equal. Right, this is equal, common side, the included angle is 90. Right, what I need to do is, I need to make sure that this plus this is minimum. Right, so A dash D plus DB, minimum. A triangle do it. Triangle. Which triangle should I go for? I need to involve this, I need to involve this. So that means I can include this triangle. Which triangle? A dash B B. In triangle A dash B B, I can say A dash B plus BB is equal to, not is equal to, is greater than A dash B. This plus this is greater than this. Now I want this to be minimum. Then that will only happen if A dash C plus BB is equal to A dash B. This is equal to this. Now if that is the case, where should D be? D cannot be here. Right? I want the distance to be minimum. That means D has to be here. Because A dash B plus DB is equal to A dash B. So D has to be on this line. And river pe dhoondna hai, so that means D has to be this point. Right? Because this plus this is minimum now because they are on the same straight line. So D is the required point. Now you can see the distance, this plus this is actually minimum. You have located the point. This is your answer. Right? Now, some people might be wondering, what kind of a question is that? I mean, you said it was a very practical question or something. Now, I'll give you an example. Suppose A and B are two villages, right? And this is, of course, the river. And we have to supply water to both of these villages. So, we have to establish a pumping station, right? We'll be pumping water from the river, obviously, right? Now, we need to decide where should we have the pumping system. Now, obviously, pumping system, I need to establish the pipe. Now, I want my cost to be least. I need to minimize my cost, right? So, I have to make sure that the length of pipe should be minimum. So, that means I'll be locating such points so that the sum of distances is minimum. In that case, I'll be using this. So, the so-called potential engineers, you should know this. Otherwise, तुम्हारी cost ही बर्बाद हो गई. We want the minimum cost people, right? So that means you should know triangle inequality. So if you want to get involved in the planning of the country, you should definitely know triangle inequality. Very important result.